Hello children, welcome to mathematics class. Today we are going to do chapter 10 of class 8, Visualizing Solid Shapes. Children, we have already done what are plane shapes and what are solid shapes in class 7. Let us quickly recapitulate our knowledge. Children, we have done plane shapes are those shapes which have two dimensions, like this shape. It has a length and it has a breadth. And what are 3D shapes? 3D shapes are those shapes which have three dimensions, like length, breadth and a height. 3D shapes, they occupy some space. Children, let us classify these shapes into 2D and 3D shapes. Now here you can see that this object occupies some space. It has a length, a breadth and some height. So it is a 3D shape. Similarly, this is also a 3D shape. What about this? Is this a 3D shape? See, I can place it between my hands. I can press it like this. It is a 2D shape or a plane shape. It has only two dimensions. Similarly, this is a sphere which is a 3D shape. This is also a 3D shape. What about this? This is a 2D shape. This is also a 2D shape. So children, we have classified these shapes into 2D shapes and 3D shapes. Children, look at this picture. What kind of a solid shape is this? Children, objects around us are generally a combination of different shapes. Like this is a combination of a hemisphere and a cone. Similarly, look at these pictures and find out. They are combination of which shapes? A tent. A tent is a combination of cylinder surmounted by a cone. A bowl is a hemispherical shell. A photo frame is a rectangular path. Children, look at this brick. It has a cuboidal shape. Let us look at this brick from various angles. If we look from front side, we can see a small rectangle. If we see from side, we see a bigger rectangle. And if we look from top, it will be like this. Look at the picture of this car. You are given three views. You have to tell me which picture represents view from which side. Picture 1 is the front view. Picture 2 is side view and picture 3 is top view. Look at this combination of blocks. Now this is the front view. And this is the side view. And children, this is the top view. Now look at this cup and saucer. Children, what do you think? How many views will it have? Will it have a different front and side view? No. Front and side views will be the same as this. And top view will be like this. Children, I have a work for you. This is a tent. Draw the front view, side view and top view of this tent in your notebook. Children, let us do a question. For each of the given solids, two views are given. Match for each solid corresponding top and side views. So children, in the first column, you are given the pictures of some objects. And in the second column, you are given the side views of such objects. And in the third column, you are given the top views of such objects. So which is the first object in the first column? It is a cauliflower. Children, can you match it with its side view? Clearly, the second picture shows the side view. So here we match a part of the first column with the second picture of the second column. And what will be its top view? its top view is given at the first part of the third column. So we match second part of the second column with the first part of the third column. Children, which is the next picture? The next picture is that of a bottle cap, and we want to match it with its side view. So here in the third part, its side view is given. So here we match the B part of the first column with the third part of the second column. Now we have to match it with its top view. Its top view is given here at the third part. Now which is the next object? The next object is a gift box. Now we have to match it with its side view. Children, can you see its side view? Yes, here at the fourth part is its side view. Let's match it with its top view. The top view is at the second part. So here we match the fourth part with the second part. Now children, which is the fourth object? The fourth object is a plate. What will be its side view? Here the side view is at the fifth part. So we match D with fifth part. And what will be its top view? Don't you think its top view will be like this? Yes. So we match it with the fourth part of the third column. Children, which is the next object? The next object is a plastic container, as you can see. And we match it with the first part in the second column here. And now what will be its top view? Clearly its top view is given here, so we match it with the fifth part of the third column. Children, look at these 3D shapes. All of these are made up of polygonal regions called faces. And the line segment along which polygonal faces meet are called edges, and the points where edges intersect each other, they are called vertices. So all these shapes, they are called polyhedrons. So this means these are not polyhedrons. Let us study what are convex polyhedrons. If a line segment joining any two points on the surface of a polyhedron entirely lies inside or on the polyhedron, then it is said to be a convex polyhedron. For example, this is a convex polyhedron, whereas if you look at this shape, it is not a convex polyhedron. Let us understand what are regular polyhedrons. A polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. Look at this picture. This is a regular polyhedron. As its faces are congruent, regular polygons, vertices are formed by same number of faces. Now look at this picture. Is this a regular polyhedron? No. Although all sides are congruent, but you can see while 3 faces are meeting at point A, 4 faces are meeting at point B. Now let us talk about two important members of polyhedron family. They are prisms and pyramids. Children, we generally associate prism with this shape, whereas prism is actually a polyhedron whose base and top are congruent polygons, and all other faces, they are parallelograms. So don't you think that a cuboid as well as a cube, they are also prisms? Yes, a cuboid is a rectangular prism, whereas a cube is a square prism. So children, what is a pyramid? A pyramid is a 3D shape whose base is a polygon and lateral faces, they are all triangles which meet each other at a common point called the vertex. Since the base of this pyramid is a triangle, so it is called a triangular pyramid. the base of this pyramid, what is the shape of it? It is a square. So it is a square pyramid. And what is the base of this? It is a pentagon. So it is a pentagonal pyramid. Children, let us take a square pyramid. Now here, the number of faces of this square pyramid are 1, 2, 3, 4 and 5. Let me denote this with F. So F is equal to 5. Now how many vertices does this square pyramid have? You can see that this is the first vertex, second, third, fourth, fifth. So the number of vertices is also 5. And let us denote it with capital V, and we get V is equal to 5. Now let us count edges of this square pyramid. 1, 2, 3, 4, 5, 6, 7, 8. So the number of edges is 8. So we get E, that is the symbol for denoting the number of edges, at 8. Now do one thing. Add F and V. What do you get? And add E plus 2. What do you get? Children, check whether F plus V is equal to E plus 2. Yes, because 5 plus 5 is equal to 8 plus 2. Now let us do this for another 3D shape, that is cuboid. How many number of faces does it have? 1, 2, 3, 4, 5 and 6. How many edges does it have? 1, 2, 3, 4. Similarly 5, 6, 7, 8, 9, 10, 11, 12. So the number of edges is 12. What about vertices? The number of vertices is 1, 2, 3, 4, 5, 6, 7, 8. We can tabulate these readings and find out whether F plus V is equal to E plus 2. Is this true for all polyhedrons? Yes, it is true that F plus V is equal to E plus 2. And this relationship is called Euler's formula. Now children, try this. Can a polyhedron have 10 faces, 20 edges and 15 vertices? Now here F is equal to 10, E is equal to 20, V is equal to 15. Let us try to add F and V. I get 25. Now we will add 2 to E, that is the number of edges. I get 22. So we can clearly see that F plus V is not equal to E plus 2. So we cannot have a polyhedron with 10 faces, 20 edges and 15 vertices, as Euler's formula is true for all polyhedrons. Mapping spaces around us. Children, have you seen a map? Yes, you must have seen a map of India or even world while studying social sciences. You must have marked neighboring countries or some places of importance in these maps. Let us discuss more about maps. Look at this picture of Rajvi's house and this map of her house drawn by her. Can you see that whereas the picture has details, a map only depicts location of objects with respect to each other. Moreover, perspective or position of the observer is very important for drawing a picture, but not relevant for a map. Now look at these two maps drawn by two siblings, Agam and Assis. They are showing the route from their house to their different schools. Now according to you, which is a better map? First one or the second one? Yes, second one, because it is using different symbols for different landmarks. He has used longer line segments for longer distances and shorter line segments for shorter distances. That is, he has drawn the map to a scale. Now children, what does this mean? A scale means how much of actual distance is denoted by 1 millimeter or 1 centimeter in the map. This scale varies from map to map, but not within a map. Children, You must have used India and world maps in your geography class. Check what is their scale and compare. So children, can you tell me whose school is nearer to house? Agam's or Assis? Children, I have an activity for you. Draw a map of your classroom using proper scale and symbols for different objects. So children, in this chapter we have discussed recognizing 2D and 3D shapes, recognizing different shapes in nested objects, different views of 3D shapes, Euler's formula, that is, for any polyhedron, f plus v is equal to e plus 2, where f is number of faces, v is number of vertices and e is number of edges. We have also done that a map is different from a picture. Maps involve a scale which is fixed for a particular map. Children, let us recapitulate what we have studied with the help of a few multiple choice questions. Question number 1. Which is a prism among the following? The first picture is that of a nail, the second of an unsharpened pencil, the third of a table weight, and the fourth of a box. So can you tell me which amongst them is a prism? Children, you can see that there are two shapes which resemble that of a prism. They are both part 2 and 4. Both of them are prisms. Question number 2. If a polyhedron has 6 vertices and 12 edges, what will be the number of its faces? You have 4 options: 7, 5, 8, 10. So what will be the number of its faces? Children, you can find this with the help of Euler's formula, which says that f plus v is equal to e plus 2. So what do you find? You will find that f, that is number of faces, is 8. Question number 3. This is a solid made of 4 cubes. Which of the following is its front view? You have 3 options as given. So clearly children, the front view will be the second one. Question number 4. This is a piece of agricultural land. It represents which shape? You have 4 options: a trapezium, a cone, a prism, or a triangular field adjoining a square field. So what is the right answer, children? The right answer is a triangular field adjoining a square field. So children, in this chapter we have discussed various 3D shapes, their different views, and also discussed about mapping the spaces around us. I hope you have enjoyed the chapter and you will keep practicing at home. Thank you and have a nice day.